For the start of Unit 2, or Unit 3, excuse me, we're going to start in on talking about exponential functions. Before we first talk about exponential and log functions, we need to talk about inverse functions. So let's first start here talking about inverse functions. Before we first talk about inverse functions, we need to talk about a one-to-one function. A one-to-one function is a function, so it must first follow the definition of a function, but it is a function where every element of the range also corresponds to only one element of the domain. The definition of a function was every element of the domain corresponds to only one element of the range. But a one-to-one function is, of course, by the name, every one thing goes to one thing. It also has every element of the range corresponding to only one element of the domain. So let's look at some examples of some functions here. Here we're looking to see that every element of the domain corresponds to only one element of the range to test if it's a function. So yes, it's a function. Then we also look to see if there's any element of the range that is corresponding to more than one element of the domain. If that's the case, it would not be a function or a one-to-one function. In this case, everything's one-to-one, so this is a one-to-one function. I'm going to use 1-1 as a shortened way of saying one-to-one. Let's do another example. Now, when we test to see if it's a function, we do see that it is a function. We don't have any repeated x values. But we do have repeated y values. And so that has a y value corresponding to more than one x value, which makes it not one-to-one. So it is a function, but not one-to-one. Okay, third example. We need to be careful and always check that it's a function first. You see right here, I have a repeated x value corresponding to two different y values. So that would make it not a function. So then by extension, it's not one-to-one because it needs to first be a function. So not a function. Okay, so we talked about the vertical line test for functions, for testing for a function. Well, now we have the horizontal line test to test one-to-one. So if I have something like this, if it passes the vertical line test and the horizontal line test, that it is a function. So you can see that vertical line is good, but then also horizontal line is good as well. So this is a one-to-one function. If I have something like this, we know that's a function because it passes the vertical line test. But if I run a horizontal line through here, you see it intersects two places anywhere along there. So it is a function, but not one-to-one. And then if I have something like that, again, it's not a function just to begin with. So it's not function, so not 1-to-1 either. Okay? So, why do we need to know if something's 1-to-1? This whole lesson's about inverse functions. Okay? A function must be 1-to-1 before it can have an inverse function. Okay, let me explain why. So, if f of x is a 1-to-1 function, then its inverse function is f inverse of x. F inverse of x. So what that says is the domain of f of x is the range of f inverse of x. And the range of f of x is the domain of f inverse of x. So that's why they have to be 1-to-1, because if you flip them around, if it's a function but it's not 1-to-1, when you flip it around and find the inverse function, at that point the inverse function is not going to be a function because it was not 1-to-1 to begin with. So then y values are going to turn around and become x values, and then it's not going to be a function. So that's the reason it has to be 1-to-1, is so it's a function going both ways. So going off of that, let's say I have f of x is, say, 2, 3, negative 5, 12, and negative 7, 2. If I want to find f inverse of x, I just flip them all around. Okay? Now what if I'm given a function? Four simple steps. Step 1 is change f of x to y. Step 2, switch all x and y. Step 3, solve for y. And step 4, let's change y to f inverse of x. Let's do an example. Let's say I have f of x is x to the third minus 1. If I go follow those steps, step 1 says change f of x to y, switch x and y. Literally, if you see an x, make it a y. If you see a y, make it an x. Solve for y. And then change y to f inverse of x. So the inverse function of f of x is the cube root of x plus 1. Another example. Change f of x to y. Switch all x and y. Solve for y. Now this one can be a little bit trickier to solve for y. I'm going to first multiply both sides by the denominator to get rid of the fraction. Then I'm going to distribute. I'm going to get everything with a y on one side of the equation. And move everything else to the other side. Factor out a y. And then divide by x minus 1. Change f of, or y back to f inverse of x. And that's it. Okay? Now, well, what does it mean to have an inverse? Like whenever you have inverse fractions, when you multiply them times each other, they undo each other. So inverses undo something. And so the way we combine functions we learned in the last chapter was we do compositions. Well, if you do the composition of inverse functions, they cancel each other out and you're left with just the x. And similarly, if you go the other direction with it, f inverse composed of f, it also equals x because the inverse is going both ways. So if we take one of our examples, let's say I have the f of x was x to the third minus 1, and f inverse of x was the cube root of x plus 1. If I find f composed of f inverse, that is going to be f of f inverse of x. So that is going to be f inverse of x cubed minus 1 cube root of x plus 1 cubed minus 1 x plus 1 minus 1, or just x. Going the other way, if I do f inverse composed of f, it's going to be f inverse of f of x cube root of f of x plus 1 x to the third minus 1 plus 1. Get the cube root of x to the third, or just x. And you can do that to test things. So say you're given, two functions. Say f of x equals x to the fifth minus 4, and g of x is the fifth root of x minus 4, and you want to see if they're inverses of each other. Well, if f composed of g of x equals x, then they are inverses. Otherwise, they're not. So if I find f composed of g, x to the fifth minus 4, well, let me back up a little bit. Let's do f of g. So that's going to be g of x to the fifth minus 4, which is the fifth root of x minus 4 minus 4. I wrote cubed, it should be fifth. So they undo each other to get x minus 4, which is x minus 8. So here, if it's not x, you can say that they're not inverses. And that's how you can test to see if two functions are inverses of each other. So we'll stop there.